All right. Welcome, everybody. It's another stream today. We're going to be continuing our progress in Godot. So yesterday I had, with the help of ChatGPT wrote the whole thing. We have this model that's working, which is Sprout, our character. And then his animation plays when I walk left, walk right. And then I can attack left and right. The only thing that's messed up is if I hold D and then release, the idle left animation plays, which determines, where he attacks. Another thing is when I attack, it stops all my momentum. So I'm trying to fix that. But I think we have something working here. I like the animation. I'm excited to make the sounds for it too. But nonetheless, that's the progress. I completely redesigned Sprout as a character. Let's see. Initially, he was a little bit bigger than 10 by 10. I didn't really understand like the differing pixel ratios, but I found out that Celeste is more closer. Let me pull it up. Pixel art. Yeah, I found out that Celeste is 8 by 8, which is also going to be useful when designing all the tiles and stuff like that. So yeah. Today I'm going to be doing some Aseprite. I'm going to be doing some tile sets. I'm going to redo some of these tile sets. These will work. However, I'm going to start by going back to the Brackeys video that I was learning from. And just kind of get a feel for Yippee. Yeah. But I am liking this. Gravity is too high. Jump force a little less. You're gonna ask ChatGPT to. Also, I found this website. This dude just has like seemingly infinite tutorials on pixel art, which is fucking insane. Whoever this is, Saint 11, you are amazing. But I was gonna use these as palettes. Each one of these, I mean, whoever made this obviously knows what he's doing with color and everything as well. And all these palettes are fucking sick. And so what I'm gonna do is, let's see. Yeah, this is just all awesome. So what I'm going to do is use these palettes for the levels. All right, so yep, we're going to go back to the brackies video. Because while the one video I was working through is good, I think the brackies video, let's see, YouTube. Back to brackies.
Then we can select our animated sprite, and let's try playing the animation. That looks great. I'm going to increase the FPS here to 10 to make it go a bit faster. I'm also going to rename the animation here to idle. I'm going to enable autoplay to make sure it plays right when we start the game. And finally, I'm going to take the sprite here and move it up to make it kind of stand on this line. And that's it for our graphics for now. We'll add more animations later. But as you can see, we're currently getting this warning here in the scene view. And if I hover over it, it's going to say that this node has no shape, so it can't collide or interact with other objects. And this is because a character body 2D is a physics node. And whenever we're working with physics, we need to define a shape that the physics engine can work with. So let's add a new node. I'm going to press the plus sign here. I'm going to search for collision shape 2D, hit create. And here in the inspector, we can now define a new shape. I'm going to add a circle shape. I'm going to make this a bit smaller and drag it up. Somewhere around there looks fine. Now you're probably thinking, well, this is pretty far from our actual graphics, but that's totally fine. Colliders rarely need to be very precise, and it's a good rule of thumb to make them a bit smaller than the graphics if you need to. Having colliders that are too large is simply going to be frustrating when playing. So let's now rename the top node here to player, and let's save the scene, Control S, as player, hit save. And now we can go into our game scene and simply drag our player in here. So I'm going to go to the top here and drag in the player. We also need to create a camera so that we can control what is currently being shown. So let's add a new node, hit Control A, search for camera 2D, hit create. And now if we press F, we can see that we have this huge camera viewport. This is definitely currently too large, so let's zoom in on our camera. I'm going to set the zoom here to 4x4 and simply click and drag our camera to be on top of the player. And now we can try playing our game. And there you go. We now have a player that is playing an idle animation and nothing else is happening. That's because we need to add a script that allows us to move around. So let's close our game, go into our player scene, and with our player node selected, let's press this Add Script button. Here we can choose a template. Of course, we're going to do some programming in this video, but writing player movement can quickly become a bit overwhelming. So for now, we'll use the basic movement template provided by Godot. Then later, we'll go in and modify it to play different animations and rebind input to the keys we'd like to use. As for the path here, I'm going to make sure that we put this inside of our scripts folder, and let's just name it player. Let's hit create, and as you can see, this creates a script that will move around our character. I know that this might look really confusing at first, but don't worry, we'll have a look at what all this means later. For now, let's just try playing. And our player immediately falls off the screen. That's because we need to give him a collider to stand on. Right now, our player has a collider, but it doesn't have anything to collide with. So in our game, I'm going to go back to the 2D view at the top here. This is where we can change from script view to 2D. Let's add a new node. So let's hit the plus sign. Let's add a static body 2D. And this is another type of physics body. It's the one we use for things that don't need to move. That's why it's called static. So it's perfect for creating some ground. Let's hit create. And again, this is going to give us this warning here that it needs a shape. So let's add a collision shape. So I'm going to hit Control A, search for collision shape. And for the shape here, we're going to create a new world boundary shape. The world boundary is a type of collider that is perfect for stuff like, well, world boundaries, because it's going to extend infinitely on the horizontal axis here. So as you can see, it's currently pointing up. We could also point it to the side here, and now it's going to extend infinitely on the vertical. I'm going to hit Control Z to undo that. Instead, I'm going to select the entire static body here. I'm going to change to the Move tool by pressing this icon here or simply W on the keyboard. And I'm going to move it down under our character. Then I'm going to go back to our Select tool, which is here, or simply press Q. And while our collider doesn't have any graphics, it's going to be invisible, we can now play. And there we go. Our player now gently lands on the collider, and we can move around using the arrow keys and jump with the spacebar. Now, our player is currently a bit too fast, and I think his jump is a bit too high, so let's modify our script to change that.
Okay, let's go to, well, I'm going to change the input map.
Let's close our game, go into our script, and at the top here there are two constants that we can modify, our speed as well as our jump velocity. So I'm going to set the speed to something less like 130 and the jump velocity to say -300. And now when we play, it looks and feels a lot better. So our player is moving around, but currently there's not much to look at. So let's build a world to explore. World building 1.0. So to build our world, let's begin by removing our collider here. We're going to build an actual ground for him to stand on. And let's instead add a tile map node. So let's press new node and search for tile map. Now, the most common way to create levels in 2D is by using tiles. In other words, we build our game world by drawing different tiles onto a grid. This is a great way to work because we can create a lot of varied levels using just a few tiles. The tile assets we use to paint are normally packed together into one big image, just like our player was. This is called the tile set. So the tile set is a collection of tiles that we can use to paint from, and the tile map that we just created is the node we use to paint these tiles into our world. So to start painting on our tile map, we need to add a tile set. So in our inspector under tile set, we'll create a new tile set. And if we press it here, we get to configure some things about it. The main thing you want to make sure is set correctly is the tile size. The tile set in our asset does indeed have 16 by 16 pixel tiles, so we'll just leave that as is. Now at the bottom here, you can see that we have two tabs. We have the tile set and tile map. So before we can start painting with our tile map, let's go into our tile set and configure this property. The main thing we want to do is drag in our tileset asset. So let's go into our assets folder under sprites and drag in the world tileset.png. It's going to ask us if we would like to automatically create tiles in the atlas. We do, so let's press yes. And now let's make some more room here and we can zoom in to view it. And as you can see, it's actually gone ahead and automatically detected the grid cells that have tiles. If for some reason it's made an error, we can always use our eraser here to remove tiles. In this case here, it thinks that the top of the palm tree is a bunch of different tiles. I'm going to use the eraser to get rid of these, and instead go out of the erase mode, and then hold down shift while clicking and dragging to turn this into one big tile. It's also split up the trees into 3 different we do, so let's press yes. And now let's make some more room here, and we can zoom in to view it. And as you can see, it's actually gone ahead and automatically detected the grid cells that have tiles. If for some reason it's made an error, we can always use our eraser here to remove tiles. In this case here, it thinks that the top of the palm tree is a bunch of different tiles. I'm going to use the eraser to get rid of these, and instead go out of the erase mode, and then hold down shift while clicking and dragging to turn this into one big tile. It's also split up the trees into 3 different tiles, but in this case it's actually something that we want, because it allows us to create trees of varying heights. I'll show you this once we start painting. Other than that, I think it looks good. So with this tile set up, we can now go to our tile map and start painting. Make sure that the scene, I'll show you this, it's
How do you
actually,
do that?
and then hold down shift to get rid of these, and instead go out of the erase mode, and then hold down shift while clicking and dragging to turn this into one big tile. It's also split up the trees into 3 different tiles, but in this case it's actually something that we want, because it allows us to create trees of varying heights. I'll show you in this case big tile. It's also split up the trees into dragons, and instead go out of the erase mode, and then hold down shift while clicking and dragging to turn this into one big tile. It's also split up the trees into 3 different tiles, but in this case it's actually something that we want, because it allows us to create trees of varying heights. I'll show you this.
Hmm.
Once we start painting. Other than that, I think it looks good. So with this tile set up, we can now go to our tile map and start painting. Make sure that the scene has the select tool and that the tile map has the paint tool enabled. And now let's simply select a tile and start painting it in. If you make a mistake, you can always right click to remove. So I'm just going to fast forward through me drawing out the level here. As you can see, I begin by blocking out the most essential game parts, leaving in room for gameplay objects like moving platforms and enemies. And then only once I'm finished with that, I start decorating. And if the trick here is that you can select multiple tiles at once to paint in more than one, and you can always go into select mode in order to select large chunks and move them. Now once I'm ready to start decorating, let me just show you the cool trick with the trees here. So let's say we want to add a tree here at the top. Well, then we can actually just paint the bottom, then choose how tall we want the tree to be, and then paint the top. So that's one of the advantages of working with tiles, is that we can also make individual elements really flexible. So once you're happy with the level, let's just go ahead and press play, and our player is going to fall right off. That's because we need to add a physics layer to our tiles. To do this, we go to our tile map, go under our tile set, physics layers, and add a new layer. Then with this layer, we can go under our tile set, and here we need to choose what tiles belong to the physics layer, because we don't want to collide with everything in our tile map. The trees and bushes, we just want to pass right through. So let's go to paint here, and the property that we want to paint is the physics layer 0 we just created. And now we can actually go ahead and paint onto our tiles these physics settings. So I'm simply going to paint this onto all the different solid tiles. And if you make a mistake and want to remove a tile, we go here, select clear, and now we can paint with no physics, or we can go back to the default tile shape, which is the entire tile, and paint with that, or simply hit F to do that. So C and F are the shortcuts here. Now, there are also some tiles that we do want physics on, but and paint with that, or simply hit F to do that. So it's the entire tile and paint. We go here, select clear, and now we can paint with no physics, or we can go back to the default tile shape, which is the entire tile, and paint with that, or simply hit F to do that. So C and F are the shortcuts here. Now, there are also some tiles that we do want physics on, but where we need the collider to only be on part of the tile, such as our bridge here. So if I zoom in on our bridge, we can see that if I just paint physics onto these, it doesn't look right. Instead, we need to go in and only paint a partial collider. So over here on the left, we can actually modify these colliders to exactly suit our needs. We can even add and remove points by clicking and right-clicking. But in this case, 4 points will do just fine, and that's a good shape for our collider. Then we can paint these onto the 3 different tiles. And then for the next one here, we can configure it. This slants up a bit. I'm going to paint that on as well. And then for the final one here, let's go ahead and make that go in the opposite direction. And here you actually want to be pretty precise whenever you have an overlap of the colliders here. I think that looks pretty good. This helps avoid that our character gets stuck. I'm also going to take the tile map and drag it to the very top so that we can always find it. And now when we play, we are indeed colliding with our environment. Awesome. Now we probably want our camera to follow the player because he's currently just running off the screen. So I'm going to make some room here. I'm going to take the camera 2D and simply drag it under the player. Making it a child of the player means that it will just automatically follow the player node. I'm also going to make sure that the camera is still positioned right on top of the player. And we can even turn on position smoothing to really smooth out our camera follow. So I'm going to enable position smoothing on the camera with a default speed of 5 pixels. And now when we play, as you can see, our camera smoothly follows our player. Awesome. So now we have a first draft of our game world, but so far everything is stuck to the grid. Let's start adding some dynamic and moving elements, such as platforms. Platforms, some that move and some that don't. So whenever we are creating a new element of our game, we begin by making a new scene. And for the root node here, I'm going to hit add and search for the animatable body 2D. This is a physics body that we use whenever we want to animate a node and still have it collide properly with other nodes in its path, which is perfect for moving platforms that should still collide properly with our player. So let's hit create and let's add some graphics. So Control A, we'll search for sprite and select the sprite 2D. And now we can drag in the texture we want. So let's go under our assets, sprites, and drag in the platforms.png. Let's hit F and zoom in. And as you can see, this is also a sprite sheet and it's currently just displaying all of them. So let's go in and define exactly which one we want to show. We can do this under region, enabled, and hit edit region. And so we can kind of crop out the element that we want to show. I'm going to change the snap mode here to pixel snap, and I'm just going to go for a default grass platform. That looks good. And now when we close it, we can see our sprite perfectly cropped out. Again, we have the warning here, so let's go ahead and add a collision shape 2D. For the shape, I'm going to add a rectangle shape, and now we can simply click and drag this to configure it. Then let's rename our top node here to platform and save the scene, so Ctrl S. In our scenes folder, hit save. We've actually created our platform. So in our game scene, we can drag it in, go under scenes, find the platform, drag it into wherever we'd like, and let's hit play. And as you can see, it works. However, one problem right now is that we can't actually jump onto the platform from underneath. To fix this, we turn it into a one-way platform. So in our platform scene, let's select our collision shape and enable one-way collision. And now when we play, we can jump onto platforms from underneath. However, the player is currently passing behind the platform. This is because the platform is currently after the player in the tree. This means that each frame, the player is drawn first, and then the platform is drawn on top. We could just move the player in the tree, but I don't want to depend on that. Instead, we fix the draw order by changing the z-index of the player. So in our player scene, we go under ordering and set the z-index to something higher like 5. By default, all visible nodes have a z-index of 0. Because they all have the same index, they are drawn according to their order in the tree. So by setting the z-index to a higher value like 5, we ensure that our player will always appear on top. And now if we play, we can see that our player passes in front of the platform. So our platform is working, but it's currently just hovering there. We might want some platforms to move around to increase difficulty. So let's use animation to do that. I'm going to leave this platform here as kind of a static platform. I'm just going to place it there. Then I'm going to place another platform over here by simply dragging it in. This is the platform that I would like to move back and forth. In fact, let me just go into the tile map and make this gap even larger. There we go. So to add animation to this platform only, we simply select it, add a new node, and we want to use an animation player. Let's hit create. And now we can add a new animation, and let's name that move. Animation players in Godot are extremely powerful because they allow us to animate pretty much anything. In this case, we just want to do something really simple. We want to go to our platform and make a keyframe under transform for the position. So I'll hit the key right here and hit create. Then we can go forward in our timeline here to say 1 second, move our platform to the right. So I'm going to click and drag. I'm also going to hold down shift to kind of snap it to one axis. Let's move it to there, and let's add another keyframe. And now we can see that if we play, the animation plays. We also want this to loop, so I'm going to select loop here. However, this is going to loop in a way that it snaps back to the original keyframe. Instead, let's press it again, and now you can see that it's going to start ping-ponging back and forth. If this is currently too fast, we can simply increase the length of our animation. So here's the length. Let's set it to 1.5 instead, and drag our last keyframe to the end. And there we go. We now have a moving platform. Let's just make sure that we set it to autoplay. And now when we play the game and go to the place where we made our platform, we can see that it's moving back and forth. And if we jump onto it, the player will smoothly follow it. Really cool. And there's already so much you can do with this. Next up, pickups. Now let's add a coin that we can pick up. Again, we start by creating a new scene. Let's create a new node, and let's this time search for area 2D. This is a type of node that we use whenever we don't want to collide with other objects, but instead we just want to define an area in which we can detect collisions. So we simply use this to detect if another body enters, such as the player character. Let's create an area 2D. Let's also add some graphics, so Ctrl A, search for sprite, and we'll select the animated sprite. Under animation, let's add some new sprite frames, selected, and let's load in from a sprite sheet here. I'm going to use the coin.png, zoom in on this, and this only has one grid cell on the vertical, and horizontally it has 12. And now we can click from left to right or simply click and drag and add the frames. Let's hit F and zoom in, set the FPS to 10 and hit play. And that's our coin animation. Let's make sure that this autoplays. And just like a normal physics body, an area 2D also needs a collision shape. So let's add a collision shape 2D. And then for the shape, let's just choose a circle shape, decrease the radius a bit. And that's actually all we need. So let's select our area and rename. And save the scene. And now we can simply drag it into our game. And that's actually all we need. So let's select our
All right, so we have we got a collectible here. That's all we really wanted. File, canvas size. Okay. Now we can go back to the tutorial.
Our area and rename sheet here.
Area, we can delete this. Where did it just go? Am I tripping? Add node. Okay.
I'm going to use the coin.png, zoom in on this, a circle shape. decrease the radius a bit, and that's actually all we need. So let's select our area and rename it to coin and save the scene. And now we can simply drag it into our game. So under scenes, I'll take the coin and place it around the level. You can always use Ctrl D to duplicate. And now if we play, we can see that the coin is here, but nothing happens if we enter the area. So it's time to make our first script. So in our coin, coin scene, we select the coin node and hit add script. This time for the template, let's just choose the default template, and for the path, let's make sure that this goes under the scripts folder. I'll create, and this is what it looks like when we create a default script in Godot. We can see that we've created the script on an Area 2D node, and that it's automatically made to function for us that we often use. ready and process. Currently, both of them only have the pass keyword, which means do nothing. So this script, if we run it, will do absolutely nothing. Now, the ready function is called right when our node enters the scene tree, which is just at the start of the game. So we can put code here that we want to happen immediately. Let's try it out by printing a quick message to see if it's working. So I'm going to write print. So since we have 5 coins, it displays I'm a coin 5 times. But we don't want anything to happen when we start the game. So I'm actually just going to remove these 2 functions. Instead, we only want to do something once our player enters the coin area. And for this, we use a signal. Signals allow us to trigger code based on events that happen in our game. Godot has many built-in signals we can use. If we select our Area 2D node and go to the Node tab, we can see all the signals on this node. We want to use the body entered signal, which is triggered whenever a physics body enters the area. Since our player has a character body 2D node, this is going to trigger the signal. So to connect it, we simply double-click it and hit connect. As you can see, this creates a new function in our script called onBodyEntered with a green arrow that shows that this is triggered by a signal. So let's here try writing a print function that says something like +1 coin. Now when we play and enter the coin area, it's going to print +1 coin. However, this message will actually display no matter which body enters the area. If we take one of these coins here and put it in the way of a moving platform, for example, this will also trigger the message. So now, right when we play, we can see that it starts displaying the message, and will do so every time the platform passes through the area. To change this, we can either use code to check what body enters the area, or we can simply put our player on a separate physics layer. Let's try that out. So under our player, we'll go to the inspector, go to collision, and here we can change the physics layer from layer 1 to 2. Let's hit Ctrl S to save, and then in our coin, we can also go under collision. We can actually have the coin itself stay on layer 1. We don't need a separate layer for that yet, but we want to make sure that it only detects colliders in layer 2. For this, we use the mask. The mask defines what layers a node collides with. So let's set that to layer 2, because that's the layer that our player is on. That should actually do it. Now our coin will only detect collisions from our player. And instead of just displaying a message, let's also remove the coin from our scene when we pick it up. So in our script, after printing 1 coin, let's add a new line. We'll call the queue free function, which is simply going to remove the entire coin scene from our game. And indeed it does. And our knight can now start gathering some coin. Now, depending on what type of loot we pick up, we want different things to happen. In this case, I want to display a score that increases when we pick up a coin. But we'll look at that when we get to text. First, I think something a bit more pressing is dying and restarting our game. Dying 1.0. So we happily move along in our world until suddenly we miss a jump and fall into the abyss. And then nothing happens. Let's change that. The first thing we want to do is limit our camera so that it doesn't follow our player when we fall down. Luckily, this is really easy to do. We simply select our camera under the player, go under limit, and here we can set a position limit for the left, top, right, and bottom part of our camera. In our case, we need to set a limit for the bottom position. To do this, we can use the ruler tool here at the top, or simply press R, and measure from this baseline here to where we would like the limit of our camera to be. I think a good value would be somewhere around, say, 120. So I'll simply go back to select mode and put in 120 pixels on the bottom. I'm also going to enable smoothing, and now when we play, we can see that our camera will follow the player, but whenever we fall off, it's simply going to stay put. Next, we need to detect that our player has entered a dangerous area and restart the game. In other words, we need to create a kill zone. I'll show you a really cool way to do this that allows us to reuse the same kill zone for more than just falling off the map, such as for spike traps, enemies, all kinds of elements of danger. And when we want to create a reusable element, we start by making a scene. Then to detect if we enter an area, we again use the Area 2D node. And let's make sure to set the collision mask here to 2. We only want to check for the player, which is on layer 2. And we won't add a collision shape here. That's because we want to be able to reuse this for all kinds of elements that might have different shapes. Instead, let's simply go ahead and rename this now to Kill Zone and save it as a new scene. Then in our game scene, we can add it by dragging it in or simply pressing the link button here and selecting the Kill Zone. And then in here, we'll add the collision shape. So I'm gonna hit Ctrl A, collision shape. And for the shape, we'll use the same world boundary shape that we used earlier for the ground. Now let's make sure to select the Kill Zone node itself, go into Move, and use the add the collision shape. So I'm gonna hit Ctrl A, collision shape. And for the shape, we'll use the same world boundary shape that we used earlier for the ground. Now let's make sure to select the Kill Zone node itself, go into Move, and use the Move tool to position it down here at the bottom. I'm gonna place it pretty far down so we're sure we don't hit this by accident. Or I mean, we're gonna be hitting it by accident, so let's make sure we don't hit it on purpose? Or I mean, I don't know. Anyways, I'm gonna place it down here a good bit away from our level. And now we can add a script to make something happen when we enter the area. So in our kill zone, let's select it, add a new script, good bit away from our level. And now we can add a script to make something happen when we enter the area. So in our kill zone, let's select it, add a new script. For the template here, I'm just gonna select empty, and the path, let's put it under the scripts folder. And now we have this empty script to play with. I'm gonna connect a signal, so go node, make sure we have the kill zone node selected, and again we'll use the body entered signal. Let's double click it, hit connect, and it's going to create a new function on body entered, in which case we can go ahead and print that you died. And now if we play and jump down, it's going to print that we died. Now, instead of immediately restarting the game, let's add a small delay. We do this using another node called the timer node. So let's add for the template here, and node into its signal. So let's double click it, hit connect, and it's going to create a new function on body entered, in which case we can go ahead and print that you died. And now if we play and jump down, it's going to print that we died. Now instead of immediately restarting the game, let's add a small delay. We do this using another node called the timer node. So let's add a new node, search for timer, and under the inspector here, we can choose some different things about it. Let's set the wait time to something like 0.6 seconds. Let's also make it a one-shot to make sure that it doesn't loop. We can then start this timer in our code. To do that, however, we first need a reference to it. Luckily, that's as simple as going to the top of our code, clicking and dragging the timer node, and holding down Control while releasing. This creates a variable called timer that automatically finds the node using this path. Now, if you haven't worked with paths before, they are actually quite simple. They specify a way to get from one node to another in the tree. So if we look at this example tree, to get from the game node to the camera, the path looks like this. It goes through the player and ends with the camera. And in our case, where we just want to get from the kill zone to the timer right underneath, we don't have to go through any other nodes, so the path is simply timer. Again, right now we're brushing over concepts such as variables and functions pretty briefly, but you can learn more about programming and what all this really means in our upcoming video on GDScript. For now, just know that using this click and drag method, we can now access our timer node using the name timer. So to start our timer, we make a new line and write timer.start. Of course, we now need to trigger some code when our timer runs out. And again, we can use a signal for this. So with our timer node selected, let's go under node, and here's the timeout signal. So let's double click that and hit connect. And this creates a new function called onTimerTimeout that runs when the timer ends. And then in here, we can simply restart our game. To do this, we first access the scene tree, so get tree, and tell it to reload, so reload current scene. So our player enters the kill zone and triggers the onBodyEntered function. This prints a message that we died and starts the timer. When the timer runs out, it triggers the onTimerTimeout function, which then reloads our scene and restarts the game. And indeed, when we play and jump off the map, we fall down and the scene restarts. Great! It's an infinite loop. Help me! I'm stuck! World Building 2.0. Let's expand on our game world a bit now that we have more elements to work with. First of all, I want to make sure that we stay organized, so let's take some of these nodes and categorize them. The easiest way to do this is by simply adding a new node. For this one, I'm just going to select the base node here, hit create, and now we can rename this. I'll make one for, say, coins, and simply take all of the coins and drag them under. And categorize them. The easiest way to do this is tab description the message display no matter which body enters the it actually yet, but we want to make sure that it only defines that's the positions from when we will call the queue free function, which is simply going to remove the entire coin scene from our game. And indeed it does. And our knight can now start gathering some coin. Now, depending on what type of loot we pick up, we want different things to happen. In this case, I want to display a score that increases when we pick up a coin. But we'll look at that when we get to text. First, I think something a bit more pressing is dying and restarting our game. Done. 1.0. So we happily move along in our world until suddenly we miss a jump and fall into the abyss. The easiest way to do this? I'm stuck! World Building 2.0. Let's expand on our game world a bit now that we have more elements to work with. First of all, I want to make sure that we stay organized, so let's take some of these nodes and categorize them. The easiest way to do this is by simply adding a new node. For this one, I'm just going to select the base node here, hit create, and now we can rename this. I'll make one for, say, coins, and simply take all of the coins and drag them under that node. We can do the same thing for platforms and any other elements that are cluttering up your scene. Now I'm going to paint in a bit more level and change the things that I don't like. And I'll put in some more gameplay elements. I'll also paint in some background tiles, but to do this we need to add another layer to our tile map. So not under our tile set, but under the tile map itself we have this layers, and this is the one we've been painting in. Let's just call this mid for midground and add another one that we can call background. Let's move this to layers, and this is the one we've been painting in. Let's just call this mid for midground and add another one that we can call background. Let's move this to the top to make sure that it's drawn first. And now when painting, we need to select the right layer to paint on. So let's select the background, and then we can start painting in some background tiles. A nice trick here is to use the rectangle tool to paint in a lot of tiles at once. And now our game looks a lot better. It has a background and a whole new part of the level that we can explore. And of course, this process is just about trying things out and making changes until you're satisfied. Enemy. A proper hero, of course, needs a good enemy. So let's make one. Let's create a new scene. And since this enemy doesn't need to collide with anything, we can just go ahead and use a node 2D as the base. Let's also add an animated sprite. So I'll search for animated sprite 2D. Let's go to animation, add some new sprite frames. Select them and let's load in from the sprite sheet here. In the pack there's both a green and a purple version of the enemy. I'm just going to choose the green one, and this is a 4x3. And I've included 3 animations here, one for the enemy kind of waking up, an aggressive idle animation, as well as one where the enemy takes damage. So I'll use the idle animation here. Let's add these 4 frames. Let's hit F and zoom in. I'm also going to move this up, set the animation to autoplay and the FPS to 10. And now if we preview, we have an animated slime. And this is where things get really cool. Because we made our kill zone into a reusable scene, we can simply use it for our enemy as well. So at the top here, I'll add in a new scene. I'm going to select the kill zone. And now all we need to do is give this a collider. So Control A, search for a collision shape. Let's add in a rectangle, fit it to fit our enemy. By the way, I'm holding down Alt to scale uniformly, and with that we can simply rename our top node here to slime and save it as a scene. Now in our game we can drag it in. I'm gonna place it over here. And if we play now and move to the enemy, we can see that just by throwing together a couple of nodes and reusing our kill zone, we've successfully added a new element of danger to our game. If we enter the enemy, we can see that indeed our game restarts. Of course, currently dying doesn't look very exciting. We'll fix that in the next chapter. But first, let's make our enemy move back and forth. We could of course do this using an animation player, just like we did for our platforms. However, I think it would be cooler to make a script that moves our enemy to the right until we get close to a wall, in which case it changes direction and starts moving left. This way we can simply drag and drop the enemy between any two walls in our game and our script will do the rest. So let's start by making our enemy move to the right. So I'll go into the slime, add a new script, use the default template and place it under the scripts folder, and hit create. Let's get rid of the ready function, and instead we are going to be using process. Just like movies, video games display motion by drawing frames and showing them in quick succession. While movies show frames at a fixed rate, most often 24 frames per second, video games generally try to draw as many frames as possible to get a smooth result. How often this happens will depend on the system the game is running on and what is happening in the game. But unless the game is lagging, it should draw a new frame at least 60 times per second, and often much more. Before the computer can draw a new frame, however, it first has to update the state of the game. What has happened since the last frame? It does this for all the nodes in our game. Then it draws the new frame. This is referred to as the game loop, because it happens over and over again, and it is really the driving force of our game. Godot of course does this automatically, but we can add functionality to the game loop using the other function in the template, process. Unlike ready, which only runs once, process runs every frame. This makes it perfect for doing things over time, such as moving an enemy. We simply make sure to change the position of the enemy a tiny bit each frame. So in our script, we can simply remove the pass keyword and instead access the position of
In this tutorial, I'm going to show you how to implement a parallax scrolling effect in Godot engine. Make sure to download and open the project I've provided in the description of this video. Basically a container for parallax to the scene. This node is basically a container for parallax layer nodes. Within the parallax folder, I've prepared 5 different backgrounds. We can use as a parallax node as a child. Then duplicate the node as a child. Then duplicate the parallax layer node 3 times. There should be now a total of 4 sprite nodes in your scene. You will see a background. However, the background doesn't repeat and there is no real parallaxing in place yet. In order to make the background repeat, we need to head back to the parallax layer and set the mirroring attribute on it. We set the X value to 1440 on all parallax layers we have. When now starting the game, the background should repeat correctly. We are now heading back to our parallax layer and modifying the scale attribute, which controls the intensity of the parallax scrolling. A higher value than 1 basically means that the object is in front of you, and lower value, 1440 on all parallax layers we have. Out to the textures from the parallax. We are now dragging the textures from the parallax folder into the texture attribute of each of the sprites. When starting the game, you will see a background. However, the background doesn't repeat and need to set its value to 1000. On all parallax layers we have. When now starting the game, the background should repeat correctly. We have the intensity of the parallax scroll layer 3 and a value of 0.2 for parallax layer 4. However, feel free and a lower value means it is further away. I'm gonna pick a value of 0.1 for parallax layer 3 and a value of 0.2 for parallax layer 4. However, feel free to pick your own value. Also make sure to set the motion scale of Parallax Layer 2 to 0, as we don't want the clouds to move with us. To make things visually more interesting, we are now adding a second parallax background and adding it as a last child to the scene tree. Assign the last parallax image as a sprite texture. On the parallax layer itself, we are now setting the mirroring attribute and setting it to 1440. However, this time we're going to set the scale value to something larger than 1, because the object is in front of us rather than behind. By default, the layer of the parallax background is -100, but since this layer is supposed to be in front of us, we need to change it. This tutorial is almost finished, but I have one more thing I want to do with you. Do you see these clouds? Let's make them move. Attach a new script to the parallax layer 2 and call it cloudlayer.gd. Specify an export variable of type float the parallax scrolling. 1440 on all parallax layers we have. We're now starting the game. The background should repeat. We can use as a background. Then duplicate the parallax layer node 3 times. There should be now a total of 4 sprite nodes in your scene into the texture attribute of each of the sprites. When starting the game, you will see a background, however, background reboot on it. We set the X to head back to the parallax layer and set the mirroring attribute on it. We set the X value to 1440 on all parallax layers we have. When now starting the game, the background should repeat correctly. We are now heading back to
Alright, well, I'm pretty happy with that progress. The parallax layer in the back is kind of busted, but it's a proof of concept, so that's good. So